Okay, this is the Algebra 1 6.4 notes to go with the Big Ideals math book. You need your student journal out to fill in with the extra practice problems. Okay, what we're starting with is exponential growth functions. An exponential growth function is in this form, y equals a times 1 plus r to the power of t. A, the initial amount, is always going to be greater than 0. It cannot be equal to 0 or less than 0. R, or the rate, is also greater than 0. It's added to 1, so we know that any number added to 1 means that this number right here that the power is being taken to, this base is going to be greater than 1, and that's how we will know it is growth. Okay, this example is not in your student journal, so go ahead and just follow along. It says the inaugural attendance of an annual music festival is 150,000 people. The attendance, which is Y, increases by 8% each year. It wants us to write an exponential growth function that represents the attendance after t years. So our variables are y and t. The important numbers here are that it is 8% and that the inaugural attendance, that means when it started, is 150,000. So what we're going to do here is we're going to go ahead and we're going to take our function we learned about right back here. So this function, this y equals a times 1 plus r to the t, is what we're working with. So we have y equals a, and in parentheses 1 plus r to the t. So our initial value is the 150,000. So we're going to go in and we're going to have y equals 150,000 times, now we are going to need to figure out our rate, and we're going to do 1 plus our rate. Our rate is 8%, but we don't add with a percentage. So remember that if we have 8%, when we're trying to go to a decimal, we move the decimal place this way 2 places, so it becomes 0.08. So 1 plus 0.08 is 1.08, and so we just rewrite our equation, y equals 150,000 times 1.08 to the t. And this is going to be our equation that will predict the attendance after t number of years. So it says, how many people will attend the festival in the 5th year? And it wants us to round our answer to the nearest thousand. So now let's just go ahead and think about this. Normally we won't take this much time, but let's just take a look. In year 0, okay, which is technically the first year, but we plug in 0 because it is after t years. So 0 is going to be 150,000. So after one more year, which would be its second year, we would plug in a 1 and we could find out that. We could plug in 2 to find out 2 years after the inaugural year, 3 to find out 3 years, and so on. So let's just make sure with our wording here. And this is what you would have if you type this into your calculator into y equals. You could come up with a table of all of these different values, or you could just type it straight into your calculator. So it says after t years. So the 5th year is 5 years. So we're going to plug in t equals 5. And we're just going to go in here and we're going to have 150,000 times 1.08 to the 5th year. And we end up finding when we plug it in, so what I did was 150,000 times 1.08 to the 5th year. And so what we get when we type that into the calculator is we get 220,399. And I'm going to go ahead and round to the nearest person. And so I'm going to say about that many people. But I did round it off because we know that we can't have 0.2115 people. Okay, so in your student journal, there's this question. So open up to page 187, pause the video, and go ahead and try it. Alright, hopefully you tried it. So it says, in 2005, there were 100 rabbits in Polygon Park. The population increased by 11% each year. And so it says to write an exponential growth function that represents the population t years after 2005. So we're going to start out, and this is going to be our initial population, so this is our A. So this is going to be our rate. So our rate is 11%, which we know if we move the decimal back 2 places is 0.11. So we have y equals A times 1 plus our rate as a decimal to the t, where t represents the number of years after 2005. So let's go ahead and write this as a very nice, neat function where we do the 1 plus 0.11, which is 1.11 to the t. And this is going to be our equation. So now on part B, it says, what will the population be in 2025? And it wants us to round your answer to the nearest whole number. So simply think, you can probably do this in your head. That wants us to do 2025, but it's how many years are after 2005. So if we subtract it, we have 20 years. So we go ahead and we plugged in 100 times 1.11 to the 20th. And you don't have to show any more work than that, but then you want to come over here into your calculator and do 100 times 1.11 to the 20th power. And we should end up, with, and we want to round this because rabbits can't be decimals, about 806 rabbits. Okay, so another type of function is exponential decay. So it's very similar in the form, but you subtract the rate because it is decreasing. A will still start out and be greater than 0. The rate will end up being between 0 and 1, and you will just subtract it. We will still go ahead and do this in a decimal form, not in a percentage form. Okay, so here's an example of a question you'll see a lot in your homework. It says determine if it is an exponential growth function, an exponential decay function, or neither. How we do this is we go ahead and we look. This is increasing by ones, so every time the x goes up by ones. So let's look at the y. From 270 to 90, that is going down 180. It's being subtracted 180. This is being subtracted by 60, and this is being subtracted by 20. So these are not being added or subtracted by the same number, so we do know it's exponential. It is going down. The numbers are going 270 down to 10, so I'm very confident in saying that it's exponential decay. So we can put exponential decay. Now, we need to justify our answer. So we don't just want to leave it like this. We want to find how it changed. So take each of the numbers. I start at the bottom and I work my way up. 10 divided by 30 is 1/3. 30 divided by 90 is 1/3. And 90 divided by 270 is 1/3. So what this means is that as x increases by 1, it's going up by 1, the y value is multiplied by 1/3. And since it is multiplied by a number that's less than 1, that's another way that I know it is decay. If this number is bigger than 1, it will grow. It will be an exponential growth function. Okay, looking right here, the x increases by 1 every time. So now if we look at this goes up by 5, up here it goes up by 10, and here it goes up by 20. So you see it's not going up by the same amount every time, like increasing 5 each time. They're varying. So that means that it is most likely exponential, and the numbers are going up, so it is exponential growth. Now, that's just the answer, but you also need to know how to justify it. So just like we wrote down here, this would be what I'd expect to see on your homework. So to look at this, when we start from the end, 40 divided by 20 is 2, 20 divided by 10 is 2, and 10 divided by 5 is 2. So what we can say is that as x increases by 1, y is multiplied by 2. And once again, as you can see, it's multiplied by a number bigger than 1, so that also signals that it is growth. But this is the type of justification we want to see on your work. Okay, this next set is your student journal. So go ahead and pause and try to do all 5. If you need to, look back at my previous 2 examples. Do number 2 through 5, and then we will check them. So go ahead and pause now. Be sure to do if it's exponential growth, decay, or neither, and explain why. But my video will show you how to do it, but somewhat quicker. So take the time and do it correctly now, and then check your answer. Okay, so here I have it all worked out. So hopefully you looked at this and you notice it's going up by 1. Here it was going up by 10, by 15, by 22.5. So this number was not consistent, so we can assume it is exponential growth. So now I took the bottom number divided by the number before it. I got 1.5. 45 divided by 30, I got 1.5, and 30 divided by 20, and I got 1.5. I was working my way back up. So as x increases by 1, y is multiplied by 1.5. So our answer is exponential growth and this description. So on number 3, it is increasing by 1 again, but notice that it's going down by 120, down by 30, and down by 7.5. So I can assume that is exponential decay because it's going down, but it's not going down by the same amount added or subtracted to it each time. So then I once again took my numbers. I did 2.5 divided by 10, 10 divided by 40, and 40 divided by 160, and I got 0.25. So I said as x increases by 1, y is multiplied by 0.25, or by 1/4, because that's the fraction of 0.25. Alright, and number 4, if you notice x is going up by 1, y is being subtracted by 10 each time. So this is a very constant change. This is actually a linear function because it's changing by the same amount added or subtracted every time. So I said it is neither exponential growth or decay, and I explained that as x increases by 1, y decreases by 10. So notice I didn't use the word multiply, so that signals that it is not exponential growth or decay. On 5, it goes up by 1 every time. Over here, we're going up by 6, up by 15, up by 37.5. So I knew it's exponential growth because we are going up, and I divided the numbers to find out 2.5. So I said as x increases by 1, y is multiplied by 2.5, or by 5 over 2. Okay, on this one says determine whether each function represents exponential growth or exponential decay. You don't have to write this down, but do follow along because we're going to do similar problems to this in your student journal. So first we're deciding if it's growth or decay, and then we are doing the percent rate of change. So looking at this number, 1.07 is greater than 1, so I'm going to say that it is exponential growth. Now, to find the percent rate of change, keep in mind it's 1 plus the rate. So, how we get 1.07, think about this is growth is 1 plus r, so we put 1 plus r equals 1.07. Subtract the 1 from both sides, and you get that r is 0.07. It wants it as a percent, so you need to move your decimal place to the right 2 places, and so it's exponential growth, and it has a 7% rate of change. That means it grows 7% over time, which is usually in years. Alright, this one, if you notice in here, this is less than 1. So that's how we know that it is exponential decay. Now, exponential decay, we know that in the parentheses, this is 1 minus r. So we can say that 1 minus r equals 0.98. Now, I'm going to go ahead and add r to this side. So I get 1 equals r plus 0.98. Then I'm going to subtract 0.98 from the other side. So I'm just trying to solve from r. And you will see in the next one, I kind of simplify my work so that you can see how it happens a little easier. But I want you to see where it's coming from the original equation. So if I know that r equals 0.02, which will move my decimal place to the right, means it has a 2% rate of decay. That means it is losing 2% over time. Okay, go ahead and look at your student journal and do the next set of problems. So it is 6, 7, and 8. Pause the video, go ahead, do the problems, and then look right here. Okay, so as you notice, this is less than 1, so it's decay. Now, I just think of it as figuring out how much it is below 1. So I take 1 minus 0.95, so I know it's 0.05 below 1, and that's 5%. You could also do it like I had showed you, 1 minus r equals 0.95, and then do the math from there. This is greater than 1, so it's exponential growth. So I can once again do this is 1 plus r equals 1.08, and then I subtract the 1, and that's where you see up here, 1.08 minus 1 equals 0.08. Write it out with as many steps as you need until you feel more comfortable finding that it is 8%. This 3/4 is less than 1, so it is exponential decay. 3/4 equals 0.75. So I'm going to take 1 minus 0.75, or I could do, since I know that this is decay, I know it's 1 minus r, so I could do 1 minus r equals 0.75, and solve for r, which is 25%. Remember, feel free to pause the video at any time, stop, rewind it, ask questions, write questions down for me later. rework problems, or even watch me do it a second time. This is about empowering your own learning. So make sure that I don't go too quickly with you and you control the video speed as necessary. Okay, so this one is a little different. This is not in your student journal. I would like it if you would write these problems up by your vocab in your student journal now, because they do show up in your homework, but they're not there as any of the extra practice questions. So go ahead, pause the video, write them down, and we will explain them. Okay, so this says to rewrite each function to determine whether it represents exponential growth or exponential decay. The reason why I cannot determine it straight off is because the exponent is not just t, it's t over 4. So what I want to do is I want to use the fact that I can use the power of a power property, where if it's a power to a power, you multiply it. So I want to rewrite this equation, and I want to say that it's the same as 0.96 to the 1/4 to the t, because we know that 1/4 times t equals t over 4. So if I rewrite it like this, and then I simply type the 0.96 to the 1/4 into my calculator, if I do this, I can find out what that decimal is and determine if it's growth or decay. So I find out that it is approximately 0.99, I guess if we rounded it to that, 0.99 to the t. This number is less than 1, and so we would say that it is exponential decay. Alright, over here, same thing with this. This is subtracting. So we know that when we subtract exponents is when they are actually in a quotient, so dividing. So this is the same as taking 1.1 to the t over 1.1 to the third. Because when they have the same base, we can take the top power minus the bottom power. So that's using the quotient of powers property from a previous lesson. So if I go ahead and I try to calculate what this is, and I plug in, let me rewrite this as 1 over 1.1 to the third times 1.1 to the t. So if I go ahead and I try to redo this, then I can do 1.1 to the third power. Alright. And I get approximately, let's see here, approximately 1.331, and I get 1.1 to the t. So this number is greater than 1, and so I know that it is exponential growth. Alright, so the last thing we need to learn about is compound interest. Compound interest is when you earn interest on a principal, that's the amount of money that you invest, and you also earn interest on the interest you've already earned. So what happens is you invest your money. It then makes money because of its interest rate. That interest rate is invested back into the account, and you make more money because now you not only have your initial amount, but you have your interest that you earned. And so it continually is invested, and that is called compound interest. That's how when you are doing retirement or savings for college, things like that, that's how your money grows. So P represents the principal amount. It's the amount you start with in the account, the initial amount you invest. R is the annual interest rate, but it is in decimal form. T is the time in years, and N is the number of times interest is compounded per year. So if it said it was compounded monthly, think to yourself, how many months are in a year? And of course you're going to say 12, so N would be 12. If it was compounded weekly, then you are going to think to yourself how many weeks are in a year, and hopefully you know that there are 52, so you'd say N is 52. And if you said daily, then we would say N is 365, because that's how many days there are in a year. Okay, in your student journal, let's look at this. So keep in mind, we're going to be using this formula, so if you want to copy it down, it's y equals p, and then in parentheses, 1 plus r over n to the nt. So I'm going to have y equals p, 1 plus r over n to the nt. So now, a $3,000 deposit. This is your p, this is the amount you're depositing. Here's 6%, so your r, if you move the decimal, is 0.06, and it's compounded quarterly. That means 4 times a year. So now we want to write an equation for that. So all we're going to do is we're going to write that y equals 3,000 times 1 plus 0.06 divided by 4. I'm plugging in the r and the n to the 4t. So now I cannot just stop there. I need to go ahead and type what's in parentheses into my calculator. So if I type in 1 plus 0.06 divided by 4, just what's in the parentheses, then I end up finding that in the parentheses is 1.015. So my equation is 3,000 times 1.015 to the 4t, and that's my answer. On this one, $5,000 deposit, that's your P. 7.2 annual interest, all right, so that means your rate, move the decimal, is 0.072, and compounded monthly, that means 12 times in a year. So we're going to write y equals 5,000 times 1 plus, put your r over your n, and then put n times t. So now once again, go ahead and just type in 1 plus 0.072 divided by 12. So you find out that this is going to be 5,000 times 1.006 to the 12t. And this would be our answer on number 10. Thanks for watching the video. Please come in with questions and make sure your student journal is all filled out. I'll be happy to help you with anything you need clarification on tomorrow.